So it's getting recorded, right?
Yes, yes.
Yeah. So our first question is valid perfect square. So a number would be given to you and you have to tell whether it is a perfect or square or not. And if it is, you just return the Boolean value, true or false. And you're not supposed to use any built-in library for this. So, and this is the constraints are like max you can have 2 raised to 31 minus 1. So how do you proceed here?
Right.
Hello.
So, yeah, go ahead.
Yeah, go ahead. So my solution was like kind of similar to what is there on the shared screen. So I took the number and whenever we do the square root, we get a float and we typecast it to an int. So we'll get rid of the fractional part and we subtract it. And I was comparing that with 0, and if the comparison succeeds, just return true.
The 2 stars here on the screen is square root.
Pardon?
On the screen, I can see the solution number star 0.5. So this is Python code. Like a 2 star means a square root.
Yeah,
Oh,
square.
Okay.
Yes, I think so. Okay. So I did it in C++, so I think I just used the sqrt function and subtract the number.
What if like you cannot use like a square root, or then how can you figure out?
Newton's method.
So let's talk about the brute force solution. Okay, what should we do to figure out a square root? Let's say like if we cannot use like a square root.
I think we should run a loop from 1 to n by 2 and check for each.
Can you guys like mute yourself? Like there is like a lot of like background noise. Yeah, it's much better. Thanks. Yeah, go ahead.
I think he was trying to talk.
Oh, okay.
It was his noise.
Just a minute.
Yeah.
So I'm saying that if we run a loop from 1 to n by 2 and check for each of those numbers whether that number is the square root of n or not.
Right.
So that can be a brute force way.
So you start from 1 and then up to the number by 2, and then keep checking at every interval, and that multiply the number by itself and then check whether it matches the given number.
Right.
Perfectly fine. Any other solution?
And we can use binary search in this range also.
Okay. Why binary search? Or
Because,
like how we can apply the binary search?
Because this is a monotonic sequence, right? From 1 to num by 2. So we can take any mid value in this range and then check for that. And if that value exceeds n, then we go to the left. And if it is less than, then we go to the right side.
Okay, fine. Do you want to like share your screen code?
Yeah, I can share.
And for like other people on the call, please chime in if you have any questions related to any approach or any questions that you have.
How do I get rid of this? Okay, so I think my screen is visible, right?
Yes.
So yeah. So I have taken the range from 2 to num by 2, and I calculate the mid in line number 14, and I check if my mid into mid is equal to the number, then that is the square root. That is, it's true. The number is a perfect square. If my mid into mid is greater than num, then I move to the left side. I decrease my right bound, take it as mid minus 1. Otherwise, I go to the right side by setting my left bound as mid plus 1.
Good.
So if I'm not able to find my, if I'm not able to check within this loop, then that means I do not have a square root.
Fine, perfectly fine. Any questions on the solution? I believe like this should be a straightforward, easy question. Given this question, like I don't think it should take more than 10 minutes to come up with a solution and come up with a solution. Yeah.
One catch here is at line 15, when you do meeting to mid, it can be overflow. So
But
other
yeah,
one thing you can, I think, can do is like you can change the calculation. It can make it like mid can go the other way, and you can do num divided by mid equal to 1 by mid. So generally, in this case, when you do multiplication, it can overflow.
okay. Okay, you're saying to take mid to the other side.
Yeah.
Okay, yeah.
I think line
Yes, it
20
can.
also. Yeah.
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 I think because here int is 32 and long is 64. No, int also 64. Okay, that's fine. Sorry.
Yes, like here I believe like we are taking the long because the number giving is int. Okay, so long will take care of the overflow, but that's like very good suggestion from C to do mid
Right.
equal to like just like in line number 15, check mid equal to number by
Got
mid.
it. Yeah.
Number one. Yeah.
Yeah.
Any other approach, any other solution? So for this solution, what should be the time complexity?
I think it would be log of num by 2.
Yeah, that is log n.
Yeah. What about like the square root one, the solution that we saw earlier?
The one I told before.
Yeah.
So that would be linear, num by 2, O of num.
Or O, what will be O1?
No, like yeah, like I'm talking about the square root one where
Okay.
we saw the Python code earlier.
Oh, the first one. Okay.
Yeah, the first
Yeah.
one. Yeah.
I think that will be constant time complexity, depending on what is the implementation of SQRTs.
It should be
Okay.
constant.
And if we don't apply the binary search, then it's order of n we talked about.
Right.
Okay. And in this case, log n.
Right.
Yeah.
Any questions, concerns?
Is square root constant time?
No, it may not be. Depends on how it is implemented.
Okay.
Okay, straightforward. Should we jump to the next question?
Yeah.
Hey, Shashank, like you can like share your risk.
Our next question is matrix we are given, which is having m rows and n columns, and you need to print all the elements of the matrix in a spiral order. So like 1, 2, 3, this is the matrix given to you. So 1, 2, 3, then 6, 9, 8. I mean, this will go like this around and we'll insert inside 1, 2, 3, 6, 9, 8, 7, 4, and then 5. So yeah, so that straightforward. It's like, so how do you like to, proceed in this?
Anyone have any questions about the question? Hope this was like pretty clear.
Yeah.
Any solutions? Any approach?
Yeah, so I kind of solved it. I'm not sure what approach that is. It may be a brute force. So basically, I decided on the direction, and so you have to move right, followed by move down, move left, and then move up. And so at each step, I was trying to calculate how much of horizontal distance I have to move, how much of distance I have to move down, how much of distance I have to move left, and how much of distance I have to move up. So my solution, like code, is a bit messy, but it's sort of worked. So mind if I share?
Yeah, please go ahead.
Is it visible now?
Yeah.
Okay, so
Can you increase the font a bit?
1 second. It's better.
Yeah, thank you.
Okay. So these are initial, edge case testing. If there is no row, just return empty vector.
So before going into the
And
code, like the approach that you mentioned was you decided on a direction.
right,
First, you are going like horizontal top row, then
right.
then go bottom,
So
and then go left, and then go up.
so
Correct?
basically, yes. So basically, first I'm trying to maintain how many elements I have to print. So that will be row into column. So this counter will decide where I have to exit this loop, right? So this will be the count I have to print. And so there are 4 loops inside this while loop. So first one moves to right, second one moves to down, then the third one moves to left, and then you move up. And apart from that, this is the horizontal distance and this is the vertical distance. So these are initialized like this. And so in the loop where I go the horizontal distance, I will be incrementing the j pointer, so which is decided like this. Basically, j is -1 because initially I was doing j++ here, and here the j was going 1 beyond the column count, so that was creating some problem. So I made it -1 and did ++j here, so that it remains within the bounds. And as soon as whatever I'm printing, I keep reducing the count. And once I'm done printing the horizontal, I reduce the horizontal distance by 1. Because when I have to print horizontally again, that will be when I'm moving left from the bottom right corner, right? And one of the element would have been already covered by when I print vertically while moving down. So similar approaches here. So you get the vertical distance and you keep printing and keep reducing the count, and you reduce the vertical distance after you're done, and then you check if your count is it, you just break out of it. And same way for the other 2 cases as well. So my aim, like I couldn't spend much time on this. My aim would be to have a better exit condition instead of a while true. I would want something concrete here, which I can decide to exit the loop.
Yep, sounds good to me. Any questions on this approach?
I think this is a good approach, but it involves a lot of code, right? And
Yeah.
I
Yep.
think for
All
such
right.
problems, you'll always have more code. And there is not much of any tricky thing in this implementation, but only you have to understand this code and implement it very properly. So that is the only biggest challenge.
So
Right.
given this problem, yeah, like given this problem, can we correlate this problem to any known problem, like data structures or like any algorithms?
Yeah, that would be great actually.
No, I'm asking like, cause when I looked at this problem, I was like not able to correlate with any. Okay, it just looks like a unique problem where you just need to traverse the whole matrix in a spiral way and then just print it out.
Yeah, actually.
Right.
So yeah, one thing I would only say, like the way he has done, mine was also similar. Like you start first from left to right, but only you don't go. In the first example, if we have three columns, I'll just go for the first two columns. And for the second one, when I'm going from top to bottom, I'll just go for the two rows. And then from
Okay.
again from right to left, I will only go for two columns. And for the other, like from bottom to top, again for two rows. So yeah, that's the only thing I will do. And I don't think I also could come much better than that. But that is what I was thinking. So as Gaurav was saying, if you have something very standard thing, if you follow always, so it will be very easy for all of us to remember these things because they are heavy implementations.
Yep. So this is like a good iterative solution. Anyone has like any other solution, maybe recursive solution?
So I solve using recursion.
Yep. Go ahead.
Yeah, can you share?
Okay. Is my screen visible?
Yeah.
Yeah.
Okay. So on line number 2 is my output vector. I've maintained it globally. And in my helper function, I'm passing the indices of my rows and columns. Like initially it would be 0 and rows -1. And for columns, it would be 0 and columns -1. Okay. So I'll come to the base cases later. So the first thing I'm doing is I'm iterating over the first column. I'll go through this example. So it would be for 1, 2, and 3. So that is taken care of in this loop, line 23 to line 25. Next, I am going one row down and I'm printing 6 and 9 from line 27 to line 29. Now, the next thing is I am printing 8 and 7 through the loop in line 31 to line 33. And the next thing I'm doing is I'm printing 4. So this is the thing. And this is for one layer. So when I go to the next layer, I'm passing starting of row +1, ending of row -1, starting of column +1, and ending of column -1. This would take care of the further layers. And now coming to the base case,
Yeah,
I'll have to
make sense. Like if you scroll down a little bit to the recursive call.
Right.
Okay, so the way like you're looking at this approach is you are given a matrix, you are looking taking the outer layer, maybe outer rectangle, and then jumping into the inner rectangle, then inner rectangle until like there are like no more
Correct.
elements.
Absolutely.
Okay, so I believe like this approach is clear to everyone. Yeah, go ahead.
Yeah. So I have made 3 base cases. So this is the most common one, that if my end row turns out to be less than the starting row, or my end column turns out to be this, so I return. So these other 2 cases are when I'll be having like I'll show through an example. So in my first iteration, I would print 1, 2, 3, 4, 8, 12, 11, 10, 9, and 5. And I would be left with 6 and 7 for the second iteration. So I have my starting row and ending row as the same indices. So I have to print just one column. So that is being done here. And the other case would be when I have one column left over, like when it's a row biased matrix, like this way. Yeah. So in my first iteration, I would print 1, 2, 3, 7, 11, 14, 12, 7, 11, 14, 13, 12, 9, and 5. And I would be left with 6 and 10. So that would be my base case when my column indices are same. So I have to, I'll be printing for the row.
So essentially, like what you are doing, if you have you are left with more than one row and more than one column, okay, then it doesn't go into the base case. Otherwise, like if there is only single row left, which is line number 8, check on line number 8.
Right.
And if you have like single column left, then you go into the base cases and then print the remaining one. Correct?
Right. Absolutely.
Okay.
So S row and E row are like start row and end row. Is that what?
Sorry.
The
S row, yeah. S
row
row is the starting row index of my current layer. And end row is the ending index.
So can you just point me in the below example, what would be the starting and the end?
Yeah, so in this case, this is a square matrix. So in this case, my starting S row would be 0 and E row would be 3. And my S column would be 0 and E column would be 2.
I see.
So this
And
is where I'm passing this row -1 and column -1.
Got it. So when you recurse, like when you go to the next call of the recursion, you reduce by 1 and the end will be reduced by 1, start will increase by 1.
Right, I contract from both the sides.
Okay, yeah. Okay.
Row +1, row -1, column +1 and column -1.
Okay. So it's like you're peeling an onion kind of thing. Okay.
Right.
Yep. Thanks for sharing this approach. What should be the time complexity for this?
Time complexity would be O of m into n, because I'm going to each of the elements. And coming to the space complexity, I think it would be O of number of elements in the diagonal by 2, because that would be my call stack.
Yeah.
Makes sense.
Yeah, sure.
Any questions? Yeah. Any other approaches? I believe like we saw two approaches here. One is the iterative one and one is the recursive one. Both approaches are pretty similar. It's just like a different implementation, iterative versus recursive. But the idea behind both the approaches are pretty same.
Yeah.
You choose the direction and then you start iterating on the boundary, and then keep going until there are like no more elements left.
Okay, then we can move on.
Yeah, if there are
There is
any
one
other.
approach in the solution. Actually, it
Okay.
is using more space though, but it is also a iterative way. It's not the recursive because I'm seeing the recursive for the first time. And actually, it's a good way. Harshit demonstrated that. But anyone
Good.
had a look at that solution?
Have you taken a look? Like, going to talk about it?
No, I'm just asking because I think he is
Okay.
going through, right? Shashank or
I
Harshit,
actually
right? This
same
is
approach.
No,
Harshit. Okay.
I just opened it
Yeah,
as I
yeah.
said.
If you can just scroll down because it's look a bit interesting because they are using that scene array, right? It's like a visited
Yeah.
array what we use, and then they are using the direction array dr and dc, and they are just doing in one loop. So I found it a
Okay.
bit interesting. Yeah.
I think this scene is for that thing only because I I can explain that. Because I think because of the scene thing, they don't have to take care of any base cases or something.
Correct.
Yeah.
Because
But
if let's say we have a 1D like a trace, one column row. So if we like try to go from left to right, and then if we come back from right to left, then we can kind of repeat elements. So maybe for that.
yeah, so you actually had taken that care explicitly in your base cases.
Right.
So that actually you need not take care of that over here, and you just use that scene array. Yeah, that makes sense.
Yeah.
Yeah, but this approach also is something
Yeah.
worth looking at. Yeah, but I'm not sure how we could very clearly come in an interview. And this one slightly maybe more, to think about in this one before implementing it. So I would
I think
actually
in
go
this
for the
one,
first two only.
we don't have to worry about those edge cases thing. We simply can maintain a 2D vector and check if we have visited a particular cell, then we don't have to visit again.
Yeah. But my worry would be like the interviewer might say, "Can you optimize on the space?" then
Yeah.
again we fall back to the first two, I would say.
Yeah.
Yeah, I believe like given the problem, since it's also like a medium problem, if we can directly come up with the space optimized solution and not using the scene array, okay, then it should be like much better in an interview.
Mm-hmm.
Okay, because definitely like we can use this approach, but I don't think like this problem is that hard. It just like how you want to like traverse that area. But yes, like there's like no issue coming up with this approach too if you cannot like figure out any other approach.
Okay.
So like,
And
does it
as
give
you
it?
said like interview is going to like again ask can you optimize it, so be prepared like to once like you know this approach, it should be straightforward to come up to the other approach with some hints from the interviewer.
Okay. Mm.
Like, does it give negative impact if like the first solution we present is not the brute force solution? I mean,
No, I don't think like it's a negative impact, but it's better to talk with your interviewer. Like if it's like very basic problem, that then like maybe the last one that we did, where we have to find the square root. Like if a number is a perfect square, okay, we can definitely go with brute force solution, and then we can talk to the interviewer. Okay, yeah, this we can apply binary search to optimize it. But if there is a problem where brute force is like super simple, it even doesn't make sense. I'm not sure. Like maybe I won't talk about it. Okay,
Right.
but it's always like good to discuss with your interviewer.
Yeah.
Right.
Because initially, whenever a problem is given, we would like to clarify the requirements. So when we have clarified the requirements, we would surely talk with some approach, right? So starting with the brute force makes sense because we are trying to evolve around that solution, and then we could come up with a better solution
Yeah,
along with the result, right? Yeah.
yeah, that is like good. And always take like maybe 2 or 3 minutes discussing like different approaches with the interviewer. The way like I've seen it help is, let's say there is maybe I've seen maybe some problem earlier. Okay, I know there is a brute force solution, there is a optimized solution, and there is a highly optimized solution. Let's say now, sometimes it happens in the interview. I don't want to go with the brute force solution. I want to go maybe with the highly optimized solution, but it's little tricky to implement. Okay, so always talk to your interviewer about, okay, like, yeah, I am aware of these approaches, but maybe this optimized approach is the one that looks easy to me for the implementation. But yes, like definitely I can solve it with this highly optimized approach, which maybe is a little bit tricky to come up right now. So it should be like pretty okay to talk to your interviewer about those. So one thing, you are not stuck with the solution that maybe you cannot come up with an interview, like in an interview, given the time frame, and you're also talking to your interviewer about, yep, you know, and there are like other optimized solutions that you can use to solve that.
Makes sense. Yeah.
Yeah. Okay, then we can move on.
Yeah.
Yep.
So we can move with our third one. So they have given a set of envelopes with width and height as a pair of integers, and one envelope will fit into another only if the width and height of one is greater than the width and height of the other. So they're asking us to find the maximum number of envelopes that you can put in that way. So if we look at this example, so if you see this width is 2 and this is 3 and this is 5 and 4. So your first 2 is less than 5 and 3 is less than 4. So definitely this can fit into this. And again 5, 4 can fit into 6 and 7, because again your 5 is less than 6 and 4 is less than 7. So that's the max, like 3 you can fit in one. So that's the answer. But you can't do, I mean, even if it is equal, you can't fit it. Like 5, 4 can't be fitted into 6, 4, although 5 is less than 6, but these two are equal, so you can't fit it. It has to be greater strictly. So, yeah,
So
so
are we
how
allowed to like rotate these dimensions, interchange them?
no, rotation is not allowed.
Okay, okay, it's not allowed. Okay.
Yeah, strictly they are prohibited.
Okay.
So what do you mean by rotation here? Because you see your explanation in the example 1, when he says the output is 3, he's taking 2, 3, which is the last element, and then you have the 5, 4, which is the first element, and then 6, 7 is the second element, third element, sorry. Right?
Rotation is like width and height revolving, I think.
Yeah.
Oh, you mean
Exchange.
within that? Okay.
Yeah. Within the list
Okay.
itself.
I think that no one would even think of, right? Okay. Yeah.
I don't know why they have given it.
Yeah.
I mean, yeah, it's weird. Like they are changing width to height and height to width and trying to fit if it can go. That way they might have too much they have thought, it seems.
Because
Yeah.
that would give another configuration. I mean, another
Yeah,
possibility. Yeah.
Because in an envelope, actually, yeah, that makes sense. If you look at as an envelope, as a physical object, so you can actually rotate. Yeah, that makes, yeah.
Exactly.
Okay, yeah, my bad, sorry. Okay.
No.
Yeah, go ahead.
Like not bad. I believe like it's a very good question, and it should be good to like clarify all those questions before you start coding or coming up with a solution.
Okay.
Because like, yes, if we are allowed rotation, then this problem becomes even more complex to solve.
Yeah, so the number of elements would double, basically.
Okay.
So,
Yeah, there will be a lot of permutations in it. Yeah. Okay.
yeah.
Will it really double?
Double, I mean, because let's say we have an envelope with this dimension 5,4, then the rotated version of it would be 4,5.
Right.
Yeah, so
But
this,
I mean, if let's take two examples, 5, 4, and 6, 7. Then I mean, when we are comparing 5 with 6 and 4 with 7, right? Then at the same time, we can come like there will be 4 combinations to check.
right.
So I think the only change will be in the if condition, right? Or maybe
So
I'm missing
double,
something.
I mean, a number of envelopes, like each envelope would be counted as 2 envelopes.
Okay, I'm not sure. I'm not sure if I understand this correctly. But okay, we can maybe discuss the solution for this first, and eventually, if we get time, then we can come up with like discuss this as well.
Yeah,
If that's fine with everyone.
that sounds good. Yeah.
Yeah.
So what should be the solution? Like any approach anyone has?
So I think let's fix every envelope one by one as the encapsulating envelope, like the outermost envelope, and we try to find all those envelopes which we can fit in that envelope, and kind of maintain a count of maximum count. So this way.
Okay. Sounds okay. Yeah.
Can we do like sort by width and then sort by height and find the common subsequence in both the arrays?
What do you mean by common subsequence?
For example,
So
2, 3 or comes before 5, 4 in if we sort by width or if we sort by height also. So in the common subsequence 2, 3 or 5, 4, they will come together.
Okay.
I have a question.
Yep.
So let's say you have one small envelope and it can be fitted into 2 big envelopes, but those 2 big envelopes cannot fit each other. So how do we do the tie breaking here? Like, will the answer be two here or like?
2, I think 2 for that case.
Yeah, it should be 2.
Okay.
Because if you're given like 3 envelopes and like let's say envelope 1 can fit in 2 and 3, but like 2 and 3 cannot fit in each other. Okay. So
Right.
the answer will be 2.
Okay.
So just looking at this problem, does it like ring a bell? Is there any like similar problem that you have solved earlier, or you know
Is it
about?
line sweep problem, like completely overlapped intervals, something like
We
that?
tried the topological sorting, but it is
I can think. Yeah, go on.
Yep. Okay. I heard about like overlapping and topological sorting. What else?
I can think of
Can
LIS.
Yeah, LIS. Look.
Can we think of
LIS.
a monotonic stack? If you sort it and then use a monotonic stack. Though I have not
Okay.
solved this, but I was just thinking about it.
Yep. Monotonic stack. Another nice way of thinking about this problem. Someone talked about LIS, longest increasing subsequence. Is
Line
that the one?
sweep?
So, who talked
Can
about
I
LIS?
share my
I
approach?
think it was Pradeep, right?
Yeah.
Or Ronnie.
Ronnie and me.
But why don't
Okay.
we sort, like we can sort, and if there is, I will not solve this, but this is just a thought process. So if you sort this right, the lowest will come, like if it is 2, 3, 5, 4, then we have a conflict between 6, 4 and 6, 7, right? So we can then sort based on height, or sort or take the biggest one. So that way you have sorted in ascending order.
Makes sense.
Yeah, I've
Nandini, like
solved it
you wanted to like share
exactly.
your screen. Yeah. Go ahead.
Okay, I'll let other one to share. I have not solved this. It was just a thought process.
No, I believe like Nandini is
okay, yeah,
volunteering
okay.
to share her screen. Yeah. Go ahead.
So I'll share my screen. So the thought process is like, so they are asking us, let me, okay. So we have to fit one envelope into the other. So both width and as well as height should be less. Then only we can fit one envelope into the other. So one thing is, first we can take only width and then see if it whether we can fit we can fit width wise or not, and then check with height wise. So if I take so my approach is like 5 given 5, and next is 6,4 and 6,7. 6,4 and 6,7, and
2,3.
then
2,3.
comes
2,
yeah 2,3. So we have width and height. So both width and height. So the box envelope we can think as if both width and height is less only we can fit into the box, or else we can't fit. Even if we take the case like width is same but height is less, like this case, it can't fit into the box, right? So what we can do is we can sort uh, either width or height, but in my case I used to sort according to width in increasing order and height in the decreasing order. For example, when I sort the list, what I will get is 2,3, and next comes 5,4, and so 6,4. 6 and 6 are having same width, but as I said, I have to sort height in the decreasing order. So I'll have 6,7. Reverse I have to do, opposite of width and height. So 6,4, right? So I'll be having 2, 5, 6, 6. Width is all sorted. So I can just leave off the width part now. So what I need to concentrate is upon the height. So if the height fits, uh, if height is in increasing order, then I can say that these many boxes fit. If not, I can't tell that these boxes fit. So if you see now, 2,3 is less than 5,4, and 5,4 is less than 6,7. So till here I can fix up the envelopes, but when 6,4 comes up, as 4 here and here is same, height is same, I can't fit it in the box. So the first step which I would do is we need to sort width given width and height according to width in increasing order and the height in decreasing order. So then what? So height width is all the we can leave off the width part and concentrate on the height part. So if we take heights of these, we have 3, 4, and 7, and 4. This is my array. So this we can solve it as longest increasing subsequence problem, which gives us the answer. Or one thing which I can tell is we can iterate over these numbers. Like I'll create an empty list, and I will insert these elements based upon the position. So if I first 3 comes up, and as nothing is there in the list, I need to check the length of the this list. So what can I do is as 3 comes up, the length of the list is 0, and so sorry, I forgot one thing to tell. So what we can do is we need to find the position of the each element in this new list. So I'm basically creating a new list. So I need to find the position of this new element which is coming up, so that I can insert into the new list. So the first number which is coming up is 3. So I need to find the position of it in the new list. In Python, what we have is we have a bisect left function, which so if we give a list and the number, it gives us the position where to insert it. What can I do is so 3 comes up, and 3, as the list is empty, it gives a position of 0. So 3 gets inserted into the list, and the next number which is coming up is 4, as so it will have the function will give this 4. This bisect left will give the position as 1, and the 4 gets inserted into the, as the length of this and the position are same, we will insert it into the stack, or else we will just uh, modify the number in place. So the next number which is coming up is 7, as so it gives the position, as the 2 elements are present, it gives the position as 2, and the number so the 7 gets inserted at the position of 2. So it will be like 0, 1, 2 indexes, and the next number which is coming up is 4. So 4, what bisect left will give is the position. So 4, this position which we get is 1, but at one position already 4 is present. So we'll try to modify the number of it. So we'll have just the new list 3, 4, 7 only. Finally, we'll see what is the written the length of this new list. I think if I walk through the code, it makes sense.
In the
So
initial, in the
what I'm
example that
doing
you
is
took,
sorry.
yeah, in the example that you took, what
Yeah.
have you modified if the width was same for 2 envelopes?
So width of 4 envelopes is same. Okay. So here what I'm doing is I'm creating an empty list. Okay. What I'm doing is first 3 number is coming up, and I need to find the position of this 3 in the new list. So this
Yeah,
bisect left, there is a function.
I understood this. I was like,
Sorry.
my doubt was with like in the initial list, like 5, 4, 6, 4, 6, 7, and
So
2, 3, you initially sorted with this to the width, right?
you need sorted with width and height.
With respect to the, yeah, okay, whatever the first, like
Yeah.
first value, the index 0 is like 2, right? Uh,
Yeah.
what if they had like 2 envelopes with the same dimensions, like with the first value same? For example, 2, 5, 4,
With
6,
the
4, 6,
first,
7, 2, 3, and 5, 3, let's say.
okay,
We
5,
already
3
have an
we have.
example here. We already have an example here, 6, 7, and 6, 4.
Yeah, 6, 4, and yeah, 6,
Yeah, my
7,
bad.
and 6, 4.
Okay, so you just, okay, you
So
basically
this
ignored it,
comes
right?
in increasing order. This numbers with all in increasing order, and this if 2 numbers are same, this comes in reverse order. That is the bigger number. I mean decreasing order of height. If two weights are same.
Okay.
That's what
My
your
bad.
question is, right?
Yeah, sorry.
Is it strictly increasing order? If it equal, would it be okay?
No, they have mentioned that if it is equal, you can't insert it.
Okay.
So they have, yeah. So here if we 5,4 and 6,4,
If
but
it is
as the
equal,
height
then
same,
why
we
we
can't
have a
insert.
decreasing order? I didn't get that part. If width is equal 6, 6.
Equal as a, okay, 6, 6. So the next thing which we have to, so if two weights are same, we have to consider them in the next thing which we need to consider is height. So height,
Yeah.
we need to sort them in decreasing order.
Why decreasing order? I didn't get that part.
So even if you don't take it in the decreasing order also fine, because when we use bisect left, it gives the actual position there. It need not be, but this can also be a way.
Yeah, I think if it equal would be okay, right? So if it equal, then we still can put it in the result.
No, we cannot. If it
Then
is
if
greater
that's the
than
case,
only.
yeah, if that's the case, why we need to have two consecutive 6? Because we have 6 and 6, they both equal. Then we don't
But
need to
that won't be the
consider that.
part of the result. 6, 6 won't be the part of the same result.
Yeah,
But I didn't get
as
that part.
widths are
If
same,
6,
only
6 is
one will get picked up, right? So both widths are same, so only one box will fit up, right? The other won't fit.
Okay, yeah. So you pick the small one,
So,
smallest one.
So 6 and 6 both widths are same, but then we need to consider height also. So when we consider height, 4 is coming up here in this 5,4. So this 4 and this 4 heights are same. So obviously this 6,7 comes up, right?
Okay.
I didn't get that
So
part still.
if
That 7 and 4, why we are keeping it in decreasing order?
I
I
think
feel like
because
sorry.
go ahead.
Though you don't keep it in decreasing order also, it's you'll get the same answer, I feel. Because 4 and 4 as it gives the position, bisect function will give the position, so this 4 gets an inserted at the same position. Does
I think it might be in this case, but in the other case, it won't. But I think why it is in decreasing order, because you're giving a chance, for another LIS to be constructed with the second 4, So if there might be an LIS which is much greater in length, so you can actually start with some other index also. You can use it, or else this won't be used at all. It will be skipped. If you have had that in sorted, so if we would have had this like 3, 4, 4, 7, so the second four would have been skipped almost. So they are just giving a chance for that 4 to be considered also in another LIS. So we could get something much better results also, if possible.
So I don't know if folks understood this, but Nandini, this is like a pretty clever way of making sure that you're not running into this issue, right? So in this example, right?
yeah,
At least the way the question is given, what you're saying is that if the numbers are same, as in if the width is the same, then you want to make sure that you cannot use both of them, right? And unfortunately, since you have sorted by the width first and you're sorting by the height later, you want to make sure that at no point of time you are putting the same width envelopes in sequence. And since you don't see that in the later part of the time, one of the clever ways you can make sure that that doesn't happen is by reverse sorting the heights. If the width is the same, then you reverse sort the heights. In that case, there is absolutely no chance that you would put the fourth envelope inside the, you put the third envelope inside the fourth envelope, because 7 is larger than 4, and there's no way that will happen. And it's irrelevant if the first value is like, it could have been easily something like, I don't know, 6,7 and 7,4 or something like that, right? So then how would you do the distinction is just by this one. So I think it's a pretty neat way. I do have a concern though, is that how does this work when like there are some, curveballs that might be thrown in the interview where the interviewer might say that, at least one of the dimensions must be less, not both or something like that, right? So there are different combinations that the interviewer can posit, and this may work for the current example, but it'll have some interesting challenges with the other ones. So I think let's move on to the rest of the question as such. But did folks get why we're doing the reverse sort on the height?
I didn't get that part.
Who's this?
Even I don't get.
Okay, so Anurag, right? So let's actually repeat this one more time, right? So here is what it is. So you've got boxes, you've got letters like 1, 2, 3, 4, 5. That's what you have examples here. And you have sorted them, right? Now you've sorted them. You've got the first envelope is with the width of 2. Second envelope is a width of 5. Third envelope is a width of 6. And fourth envelope is also a width of 6, correct? That's what we've done, right? That's what Nandini has done by sorting.
Right.
Now, what you want to do is you want to do the longest increasing subsequence on the heights, and whatever the answer is the correct answer, right? Now the problem that you have is that when you do the longest increasing subsequence, you are completely ignoring the width at that point of time, correct? So what would happen is that if you had this as like, if you had the 6,7 and 6,4 flipped, then it is possible that you may choose your answer as 2,3, 6,4 and 6,7. Right? Because
so can I give an example for that?
Yeah, go ahead.
So I'm only concerned if I only concentrate on the height part. So what I will be having is 3, 4, and 4 and 4. So if I so I'll have the longest increasing subsequence as the whole length, right? As length as 4, as 3 is greater than 4 and 4 and 4, and then so either it longest increasing subsequence, if they, even if we consider equal case, we'll have 3, 4, 3, 4, 4, 7. If we don't consider equal, 3, 4, I think here also the same comes up. So this will be 4 will be the longest increasing subsequence, right? But 4 and 4, as the height is same, which can't be fit in the box, in order to make sure, so 3, 7 and 4. So here we are breaking the chain by sorting in the reverse order.
Pretty clever trick. Nice, nice way of doing this. So let's move on. Let's continue with the rest of the.
Should I explain the code?
Before you go into the code, right? I think there was one more thing that when I was solving this question, one thing that helped me think about this question was around what we're trying to do is like longest increasing subsequence, right? The way it generally works is you're trying to find the longest sequence that ends with the current number for every value, right? You're trying to figure out, like, if I do, for example, if you had 3, 4, 7, 4 as your array, then what is the longest sequence that can end with 3?
Okay.
That's just a sequence of size 1. That's just 3. Correct? What's the longest sequence that can end with 4?
Yeah.
That's essentially all the numbers to the left of 4, which are less than 4, and whatever has the greatest value of that. Right? So if you, and that is essentially, you can make a sequence which is 3, 4. And that's why the longest sequence that can end with the second 4 is 2. The longest sequence that can end with a 7, you can put the 7 on top of the 3, or you can put the 7 on top of 4, And obviously putting the 7 on top of 4 is the best example. So that's essentially, if I were to use an OGS data store, I would put 1 below 3, I would put 2 below 4, and I would put 3 below 7, right? Now, instead of the last one being 4, let's say it was 5, right? If it was 5, then I can put that 5 on top of 3, so that will be a stack of 2. Then I can put that 5 on top of 4, that will be a stack of 3. I cannot put the 4 on top of 7, so that will still be a stack of 3. So the answer in that case would be 1, 2, 3, and 3. If the last one had been 4 or 5 instead of 4, and if it's 4, then it will be 1, 2, 3, and 2. And the longest stack that you can make is this. So the way I think of it, at least when I originally started with this sort of problems, is that you're trying to always determine what is the largest or longest sequence that you can make that ends at that particular number at every point of time. And whatever technique that you use, whether you use like a stack or a tree or whatever, is up to you. Right? With that insight, I think you'd be able to keep the question and the problem solving pretty straightforward. Does that make sense?
Yeah.
So I have another approach. So I have sorted these envelopes on the basis of their areas. And then I kind of did exactly what Vivek has said, use the concept of LIS.
Okay.
But in
So
area,
you
how
want
will
to
you
explain?
which one will you get
Area might
inside?
be same for 2 dimensions of different values, right?
Yeah, exactly. That
Yeah,
can
so
create a
I've
problem.
maintained a class.
And
Yeah,
width
I can
and
share my
height
code. Like,
also can be interesting. Yeah.
You can finish your
I can share.
Could we finish with this one first? Can we
yeah,
look at the
let us
code?
Yeah.
look at
Right.
So you are able to see my screen, right?
yes.
Yeah.
Okay. So as I said, I'm sorting these envelopes in increasing order of width and decreasing order of height. And what I'm doing is I'm just taking the height and passing to the helper function. At each so this LIS list is a new list which I'm taking for inserting each and every element at the correct position. So it's like a sorted this LIS LST of sorting numbers. List of sorted numbers will be present. So I'm iterating through these numbers, these heights specifically. So at first 3 comes. So LST is initially empty. So when 3 comes, what a bisect left will give is the position of that particular index in this LIS LST. So if the position equal to the length of the list, I will just append it to this list. If not, I will just change the at that particular position. I'm changing the number. And finally, what I'm doing is I'm returning the length of the list. So for more clarity, uh, 3, 4, and 7, and then 4 are coming up. So initially my list is empty. So what this bisect function will give is have is list and the number 3. So what it gives is the position. It gives a position of 0. So the new list will have the 3 inserted at position 0. And the next number which is coming up is 4. So this bisect left will have the list 3 and the number 4. So which gives a position of 1. So 4 gets added, and the next number which is coming up is 7. So this 7 gives the position, this bisect left gives the position of 2. So as position 2 is equal to the length of the list 2, I'll just append it. So 7 gets inserted, and the next number which is coming up is 4. So this bisect left what gives a position of 1, as 1 is not equal to the length of the list, that is 3. As 1 is not equal to 3, it will enter into the else condition, and the LIS this list at the position 1, it will get updated with a new value 4. If not, if some let's say some 5 comes up here instead of 4, sorry, 5, then also like it gives the position of 2, so which is not equal, so we will have 3, 4, 5, and finally we will return this list as our answer, length of the list as an answer. Does it, is it
Time
clear?
complexity. Regarding time complexity.
So yeah, this bisect left actually is a binary search.
It's a binary search, yeah.
Okay.
Binary search where it gives a position.
Okay.
But I think in interview we are not supposed to use that, right? We have to explicitly write binary search function.
So it's like using a
Yeah.
set in C++, right?
No, Python.
You use.
No, it's
Here I've
analogous to
written
using
code
a
in
set in C++.
we can write the binary search with where it gives the position of the it must be inserted.
Yeah,
It
I think
can
that
be
is
done also.
fine. Yeah.
So on line 11, they expect the position to be equal to the length of the LIS
Yeah.
list. So you can append it, otherwise you just replace it.
So what we have is the numbers must be in the increasing order, right? Height. So I'm just basically checking if the position is equal to the length of the list. Then I'm just appending. So something greater element is coming up, so I can add it to the list. If something smaller is coming, I'll add that particular index. I'm just changing the value of it.
But what if that smaller value is not available in the list?
Sorry?
What if that smaller number is not available in the list? Can that happen?
So it will give the next
Smaller
greater
number
element. Next greater element of that value.
Right.
Yeah.
Okay.
So it's like the lower bound. Yeah. In C++.
So this gives
On line
maybe
14, when you replace it, would it make it out of sequence? Because now it could be the later one now could be in front of the larger one.
So the next number, my case, which is coming up is 4, right? So this bisect left will give the position of 1. So here, this 1 position it is giving up. So as the length of the list is greater than, is not equal to the position, 1 is not equal to 3, it will end, go into the else part, and this number gets updated. Like here in our case, 4, again 4 is coming up, so 4 will go instead of 4, again this new 4. Some instead of 4, if some 5 value is coming up, so this 4 gets replaced with a value of 5, and this will be our
yes, but that 5 will be after the 7, right? Then it's not a long LIS. Would it, okay,
it's
so why
LIS.
now we have 7 and now the next one is 5 and we put 5 in there. But that 5 come after 7.
But we already have a LIS, greater LIS for 2, 4, 7 or whatever was that earlier, right? So that value is already stored somewhere, right?
It's sorted actually.
Yeah,
Yeah,
this
that is already there, part
LIS,
of it. Yeah.
LST, it's all already sorted. We are not append. So we are considering the position and then appending, right? Checking whether the position, if it is equal to length. Maybe you, for better understanding, if we don't consider this if part, so whatever the position is coming up, we are inserting at that particular position this number which is coming up.
I think you are creating a unique sequence. Even if the height is like, for example, you have 2, 4, 2, 3, and 6, 4, right? 2, 4, comma, next list is 2, 3. Create next list as 2, 3. And next one is 6, 4. No,
Okay.
you take this as an input, 2, 4, 2, 3, and 6, 4. You can remove that 2, 3 in between.
Okay. 2, 4. So this is the input which you are telling.
Yeah, 2, 3. 2, 4, comma, 2, 3.
Okay. 2, 4, comma 2, 3.
Yeah,
This
here
is the
in
input.
this, yeah, if you arrange according to the sorting order of yours, it will come as 4, 3, 4, right?
4, 3, 4.
Yeah, for the
So
list,
let me
for the
walk
height
through.
wise,
So,
if you pass it to the helper function, it will get as 4, 3, 4, right? The nums, the
so
list will be 4,
actually
3, 4.
list this LIS
No,
LST list.
So he is saying to take only the heights after this. This is the
Yeah,
input
after
actually. This is a
yeah,
complete
this is the input. If you take the only heights like 4, 3, 4, so that will be the height you
Okay,
pass
okay.
into the helper
4,
function.
3, again 4, right?
Yeah.
Okay. So at first, initially
Yeah,
4
I
will
think
be
you are
coming up.
creating it unique, right? Like you are just creating 4, 3 here, like, because the bisect will
Yeah,
give
this
you.
4 position. Let me walk through for this example. So initially 4 is coming up as my list is initially empty. So this bisect this position will give me so this initially list is empty and the number which is coming up is 4. And the position when I pass this 10th step, what I will get it is position. So initially as my list is empty and the value which I'm getting is 4. So this bisect left will give me the position of 0. Then what happens is at 0 at the position, I'll insert 4. And the next number which is coming up is 3, right?
3, yeah, you
So
will insert
3
3, yeah.
position will have a value of 0.
Yeah.
Yeah. So so 3 will have a position of 0 and position which I will be getting 0, but the length of the list is 1, right? Length of the list LIS LSD equal to 1, which is not equal, right? So
Yeah,
what
go
I
ahead.
will do
Yeah,
is
go
I'll
ahead.
get into the else part. In the else part, at this particular index, 0th index, my value gets updated to a value of 3. So this will be present in the list. And the next number which is coming up is 4. Next number which is coming up is 4. And the length of the list is now, so for the 4 will have the position of 1, and my length of list is also 1, so it will get appended at the last. So the final list will be 3 and 4. So this length of list is my answer. So 2 will be my answer.
Yeah.
Yeah.
That's the correct implement.
Any
Yeah.
doubt regarding this? Or should I be more clear through the loop part?
That's fine.
No, I think that's fine.
Yeah. So any doubts?
So for the original example, After the
Hmm?
sorting, you know how the 6, 7 comes before the 6, 4? If the 6, 7 comes after the 6, 4, your code will still work, right?
Yes, yes.
This helper function you're talking about.
Yeah.
Because she's sorting, right?
No, I think it is sorting is not necessary here, I feel. Even then it will work.
So for this
Like,
example, it's fine, but we'll have to sort it, right?
like on line number
Yeah,
19, you have a minus chord of 1. So I
yeah.
just wondering
So
if you
this is
put a plus there,
plus.
it still works. Yeah. If that's a plus,
Uh,
it still works.
no, it won't work because here I'm this according to the position I'm inserting the values, right? Let's think that if we don't have that in the sorted order. So let's say we have 3 comma 4 comma 4 comma 7. So if I don't sort, this will be my answer, right?
Yeah, so the
Yeah.
minus chord 1 is for
Height.
the descending order of the equal heights,
Yeah,
right? Okay,
yeah.
equal weights. Yeah, then
So
that
when
is
I
required,
keep
right?
this,
That is what we
it
discussed earlier.
change to 3 comma 4 comma
7 and then 4, yeah.
4 descending.
Yeah, that was the first thing what
So
we discussed
here
when we was talking about
for the
that, right?
position,
Yeah, yeah, yeah.
yeah,
Yeah, yeah. That's the only way, the trick which actually works over here.
Exactly.
yeah.
Yeah.
Maybe I mean maybe we don't get immediate idea of this reverse, but for the few test cases, if we check, it will not work out. Then we
Yeah,
can
it
think
makes
about
sense.
we'll get a thought of sorting in the reverse. And from this also example also we can understand like here 2 comma 3 5 comma 4 is there and 6 comma 4 is also there, but 5 width is less than 6 but height as these two are same, uh, but this case won't come up, right?
Yeah, you
As the heights of this 5 comma 4 and 6 comma 4 are heights are same, so
yes,
obviously
basically.
we need to sort in the decreasing order. I
Yeah,
mean
I
I
see.
too didn't get the this then later point I just uh, use this uh, in the
Yeah, I would say take
I
different
got in.
examples and actually walk through that, so things will be very clear, because
Yeah,
this sorting is slightly tricky. So unless you actually put some numbers and actually do some printing on that on the standard output, you will actually won't get it very clear.
yeah, but
So that's the
with
best
the
way to do it.
sorting comes into mind because I mean as we they said we have to insert I mean width and height of one envelope is greater than the width and height of the other envelope. So at least one sorting we have to do that comes into our mind, like as I said, it should be always greater. But second sorting, as we have some examples and we can understand that we have to sort in the reverse if two widths and are same something.
Yeah.
I have one doubt here.
Hmm?
So let's say your input is 5, 4, 6, 7, 6, 8, and 2, 3.
5 4
6, 4,
5 4
6, 7,
6 7
and 6, 8,
6 8.
and 2, 3.
Okay, 2 comma 3, right?
Yeah. So,
So 2 comma 3 comes first and then 5 comma 4 and then 6 and 6 heights are same, so I need to jump to the height part. So 6 comma 8 comes and then 6 comma 7 comes.
okay.
Yeah,
Yeah, that is not part of the trend. That's a parameter. The trends only render the trend, the bottom part of it, and the and widget. The
Hello?
other one was the parameter widget that
Hello?
not part of the
Maybe
trend, but
you
I
want to
will
mute someone,
really
host.
update it.
Can you mute Leon for some time? I think he's on the other call.
Okay.
Okay.
Shashank?
Yeah.
Nandini, you need to unmute yourself.
Sorry. Okay. So this will be my sorted
Yeah.
sorted
So this is
envelope.
almost like the first example, right? So now we will have 3,
Yeah.
4, 6, 3, 4, 8, and 7. So we will only get 3, 4, 8 as our subsequence, LIS, right?
Yeah. Yes. As this position gets replaced, we'll have the length of 3 only in our answer.
Right. So that will be only size of 3.
3, 4, 7 could also have been, I mean, LIS.
Yeah, 3, 4, 7 or 3, 4, 8, whatever.
Yeah.
So I
So
think.
time.
But what we want is count, right?
Yeah, exactly.
It's only the length, yeah. So if the doubts are cleared, can we move to Harshit's solution also, what he was talking about?
Sure.
I think someone had a question on that. Is that okay? Or
Harshit is, I think, not the.
Ajay Kumar, right?
Yeah. I'm clear.
Okay. Yeah, Harshit, could you come up with your solution?
Yeah, so I'll explain through the code only. Is that okay?
Yeah. Okay, go ahead.
Yeah. Okay. So what I'm doing is I'm maintaining a class where I'm storing the area, the length, and the width. And so I make a vector on line number 18 where I'm storing these triplets, and I put these triplets in this vector. So first element is the area, length into width, second is the length, and the third is the width. And I put this in my vector. Now what I do is I sort based on the area. Okay, so basically I've sorted on the areas of these envelopes. So the next thing I do is I do a LIS kind of thing with one check. So I take two loops, I and j. I is from 1 and j starts from I minus 1 till 0. So if the length of I is equal to the length of j, or if the width is equal to, then I move on, because it's mentioned in the question that it has to be a strictly monotonic sequence. Otherwise, if the length is greater than the length of j and the width is greater than the width of j, I do this thing, maximum of 1 plus res of j. So res is a vector which would store, so res of I denotes the largest increasing subsequence ending at res of I. So initially, let's say I haven't yet started my computation. So in that case, each possible sequence would be of length 1. So that is what I've initialized my res vector with. Now, if I hit this condition where my length is greater than the length of an envelope to the left of my current envelope and also the width, then I do 1 plus res of j. I take a maximum of these two. So at the end, once I'm done finding for one particular I update my answer variable. That is ans of res comma I, and in the end I return ans.
Okay, so your answer is always keeping the max so far value.
Right.
Okay.
So what is the significance of calculating area?
So area, I have calculated the area because if you kind of visualize the situation, we are going from larger to lower areas with this condition, which I've made in line number 37. If the lengths are equal, then I'm not considering that those two envelopes.
Okay.
Yeah.
I basically did the same thing, but just without the area.
Yeah, so this is a different way of doing it. Yeah, yeah, that's also a good approach. Yeah. Yeah. So Ronnie is saying that he did it without an area. Okay.
Okay, Ronnie.
But the rest of the thing is the same, right?
Yeah, rest of everything is same.
Okay. Makes sense. Yeah.
So here the time
But Ronnie, do
complexity will
you?
Order of n square it should be.
Yeah, n square plus n log.
Yeah.
Yeah.
So n square.
Yeah.
yeah.
But it's just showing that we have another approach also to do.
Exactly.
This also is some different
Yeah.
approach. Yeah. That makes sense. Yeah.
Yeah, what Nandini explained was very clever. I mean,
Yeah, that's most optimized way of doing it.
right.
That is true. Yeah. But if you can't come up with LIS, sometimes it's very difficult to come up with that LIS, you know, the descending part of, usually. So then if we can get this one also, then that is also fine. Yeah. Okay.
I thought this should, I thought it will not accept n square solution.
You are saying this is not an exact n square solution?
No, I'm saying I didn't thought that the summation will accept an n square solution, although it accepted it. But I mean, it's not, because the constraints are not mentioned there, so I was just wondering. Anyway,
But I don't think so. It is an n square solution though, right? Does it?
It is. It
Exactly. Not. Upper level it's n square only.
Yeah, this
the
thing.
worst case
I'm
would be
going.
n square.
But J actually is going from I to 0. Okay, but then you are continuing also. Okay. Yeah.
So every time from current index to 0 he is going.
Okay.
Yeah, current minus 1 to 0.
Yeah. Okay, no problem. Yeah, thank you.
Okay.
I will still encourage people to first go and solve longest increasing subsequence problem. Okay, so you have a better understanding of how LIS can be solved, and then this question I see it as an extension of LIS.
Yeah.
And there are further
this
questions
problem,
that Vivek posted. They are pretty
this is a
similar.
very similar problem to what. If you want, I can share in the chat.
Yeah, no problem. Yeah, do that. Yeah, but Gaurav
Can you
saying
instead of
is that
sharing on chat, share on the Discord channel itself?
All right. Okay.
yeah.
I will share my LIS solution on the Discord. I just had a LIS and then I extended it to solve this Russian doll.
Okay. Do you want to share it here so we can go through that?
Okay, yeah. If you guys have time, maybe I can share it quickly.
Yeah, we can do it. Yeah, quickly.
Yeah,
please.
Let me share on the Discord because looks like I have a new machine and Zoom is not set up for screen sharing. I need to quit and then join again.
Okay, no problem. Yeah, that will go.
That's fine.
Okay.
Okay, great. Thank you.
Yeah. Thank you.